Okay, so why the fuses are used? Why the fuses are used? Fuses are a strip of wire that burns out when the current becomes too excessively heated. So the fuses will prevent all the devices from damaging due to excessive current or heat by melting down and by opening the circuit up from the closed circuit.
Essentially, what kind of circuits are used in homes, is the question. And generally, it'd be a parallel circuit that's used in a home. I mean, given this, this, for example, would be set up on a parallel because all of them light up at the same time. But this entire thing, this entire bulb, has to be a parallel circuit because this is independent of this, and which is independent of that. Most of the lights and the fans are independent of each other. I think basically every device in your home would be on a parallel circuit rather than a series circuit, because a series circuit would use up all of the 120 volts at once, whereas a parallel circuit would allow you to supply the 120 volts to all of the devices that needs 120 volts. Yeah. So the question is approximately resistance in the homes. That's not even a question. But the resistance in the homes, there aren't actual resistors in homes like you generally find in like electric house projects, because the light bulbs themselves generally have enough resistors themselves. Also, the resistors, resistors generally are, light bulb is a classic example of resistor. Look up over there at the light bulb. Because what happens is these filaments grow hot and get heated up, and they take up a lot of the current in order to produce light. And the heat that they make because of the voltage they take up makes the light. But besides that, yeah, that is basically.
Hi, I'm Mr. Brooks. I'm going to be talking about the step down of the power plant. You get your electricity from the main power plants, and that's where it's, huge voltage. Just humongous voltage. I can't compare to these brainiacs. I'm gonna sound really stupid. I apologize. That's just how it's gonna be. Anyways, so you have a lot of power in the power plants, and it goes to a step-up transformer, which brings the power to the power line. It goes from the power lines to a step-down transformer, which brings it to the houses and the small businesses or wherever it has to go. And the reason for the step-down transformer is to make it safe for use.
Why do they step up?
And that is because high energy transitions have less waste than low energy transitions. And anyways, when you get to the house, the power goes to a circuit board, and there you can control the power throughout your house. I'm sorry for laughing. Just Josh back here is making fun of me. Let's see, from the circuit board there are parallel circuits that go through your house. I'm not laughing. They go through your house, and from those parallel circuits you have more parallel circuits in a series or something like that. I don't really know. And that's why when one of your circuits goes out, it will only shut the power off in that area and not in the entire house. And that's why we divide the house into circuits so that your entire house does not shut down.
So, the last last thing you wanted was us to relate our research findings to the process of building and developing the design and whatnot. Anyway, what we did was a lot like an actual house because we used so many parallel circuits. Basically, we had two master switches, and off of those two things, everything ran. One master switch controlled the right side of the house, and the other controlled the left side of the house and the doorbell. The right side also controlled the elevator because we needed to kind of balance them, because otherwise one would be way too heavy and we wouldn't be able to fit them in. But we did divide our house into two circuits, so that way at least if one breaks, we at least have the other one working and functional. You wanted us to describe some of the problems we went through. Oh boy, where to begin? All three of us should chime in. So chime in whenever you have anything you think was a problem. Alright, so the
elevator.
First problem, the biggest problem was the elevator. And I did the elevator, so yes, the problem was mine. But, first I connected the diodes wrong. Second, some of the connections were faulty because someone couldn't solder correctly. That wasn't to you, Brooks. That was to the person behind the camera. Then I guess we also had to cut out some more space because the elevator was kind of big. Getting the limiters working was a hassle.
The whole house working was a hassle.
Getting the whole house working was a hassle. We had a bit of an incident where we thought that everything had broken. Like, we were panicking, but it turned out that Daniel kept connecting the wrong wires to the battery.
No, it was connected like that before.
Yeah.
I didn't connect that.
All
way.
right. Anyway,
You
moving
want
on.
to defend yourself?
Okay, I'm gonna defend myself. No, I didn't connect the wires. It was connected that way. Somebody connected it, and I discarded it, and then I tried to connect it, and it worked. So whoever did it, it's your fault. And then my problem was, here, look, I have 3 floors. The second floor, we just got rid of it because it worked originally, and then somehow it doesn't now. Anyways, look at all the lights I did. 1, 2, 3, 4, 5, 6. 6 rooms. Haha. I'm awesome. Bye.
Yes, as you can probably tell, Daniel did all the lights in all the rooms, which was a big deal. I did the doorbell and the elevator because the elevator was a hassle. I mean, that elevator took me long. Sam did all of the soldering, and he did splendid work, very good work. We all took part in some of the. Sam also did the recording, of course, as you can probably tell. But we also took turns doing the glue gunning and like basic troubleshooting. We all helped out with each other.
And your video edit.
Daniel and Sam both helped pack up the tidy everything up while I was still working on that elevator. But anyways, another problem was the doorbell. The doorbell was a bit of a trouble because we first hooked them up in series, and then we realized that there wasn't enough power flowing through, so we had to put them in parallel. The lights were trouble because we used LEDs, and we had to either make enough resistance on the circuit, or we had to use resistors in order to actually use them correctly. Doing all the switches was a hassle, especially since we bought some of the wrong switches. So some of them were toggle switches, and so that's why one of them goes backwards and forwards, but only works forwards.
Where is
So,
that?
anyway.
Okay.
These ones.
Yeah.
We didn't even open this.
Yeah, we bought these a lot, like
This
three
is a
or
false
four of
switch.
these kinds, and so it kind of sucks. And finally, we didn't have enough wires. We could have used some more wires. And that's about it. So thanks for listening.
Thanks, Mr. Brooks.
Thank you. Bye.